because I knew this was going to be a lot, and because I know that it is November 5th and we're all exhausted from the semester, I thought I would build an example that sort of gives us like an overall review of all the stuff and put it like from start to finish, like how you might go through a problem.
Ooh, exciting.
Exciting. Now this data set is different. This is a new story. We're done talking about income. This data set comes from chapter 2 of the longitudinal analysis textbook that I wrote over a 5-year period and published about 10 years ago. And the whole textbook is about longitudinal models, but this chapter 2 is only about cross-sectional models, general linear models. And the reason I chose to do that is because, in particular, if you don't know what a slope is, and if you can't interpret an interaction term, which is the next thing we're going to do, then longitudinal is going to be way harder. So I set this up as a review for that purpose, but then I'm also using it for this purpose. So these are fake data, but they were simulated to have the variables and distributions and storyline of a real data set that I have done analyses on. So these are 550 fictitious older adults. The context of this study was a longitudinal study of the oldest old. These are actually twins in Sweden in the 80s and 90s who started the study between 80 to 100. I think I've had too much coffee. So in this data set, we are predicting cognition as our outcome. It was measured in the original data set by something called the information test, which is a measure of crystallized general intelligence, so just facts and stuff like that. It's a sum score. So we are predicting it from quantitative age, quantitative grip strength, which is like, what? But in cognitive aging, yeah, pounds per square inch. In cognitive aging, this is often used as a proxy for some kind of physical capacity variable, for better or worse.
Yeah.
They had it in the data set, so that it's grip strength is what it is. I have a binary version of sex, and I have a 3-category version of a variable for dementia diagnosis. So this is whether or not they've been diagnosed with some kind of dementia, either never during the study, eventually during the longitudinal study, or they walked in the door with it. So as you can imagine, not a lot of people in the 3rd category. So this is, I would say, an ordinal variable. I'm definitely not going to put a slope through it because I can't assume that the difference between none and future is the same as future to current. So we're going to treat that as a typical grouping variable, and we're going to make none the reference. So then the order of models here is sort of based on what I did in the book, but it's also based on what I would expect in terms of like analyses on this kind of data. First thing I would need to do is control for age. No one's going to listen to me unless I do that. Then we're going to control for some kind of physical capacity, and then we can get into sex and dementia diagnosis. So we'll start with bivariate relations of each of these things and then build our way towards a combined model and note the milestones along the way. Okay, so any questions on the setup for this?
Is there a reason for the 2 and the, if there was a definite difference along the way, would you have current first, then the future? Or would you have future before current?
I think it's up to you whether you want this to be dementia progression or like skills.
Okay.
So I would expect that scores get lower as you progress along these stages. So this, I'm expecting negative slopes, and like this variable is a bad thing.
Okay.
If you wanted to phrase it an alternative way, then you just talk about it differently.
Okay.
Yep. So I have an example of the sequence of this. The actual reason I picked this sequence was to demonstrate quantitative predictors and then binary and then grouping variables. Like that was the true motivation. But all right, so first things first. In the examples I've shown you this semester, I've had pieces of code where it's like, build the variables, build the model, build the variables, build the model. In practice, I don't do it that way. Because if you do it that way, when you come back to your code, you have to hunt for all the sections that you need to run selectively that builds the variables. So in practice, I always put that near the top, and I build everything in one fell swoop. That way, to recreate the data set, it's all in one nice section. So just to review coding, we'll do stata and then R as usual. So what am I doing here? What is the purpose of this statement?
Find out where it's located.
Where what is located?
Your data set, your file.
Not just the data set, but everything. So CD stands for change directory, I think. This is a folder location.
Mhm.
So I'm saying start here when you're looking for stuff, and anything that I'm asking to save, put it there. So everywhere down below, there's an implicit reference to this place before the name of any file. And there's ways to make more than one of these. That's a different command, but this is the place that you're telling it. So this is where your stuff is going to be, not the file, but the folder. If you are using the virtual desktop, you need this piece in front of it, //client/, because that is taking it away from the server's hard drive and onto your local ones. By the way, do you see how this has comments in front of it and it's green?
Mhm.
So this is something you can do when you want to have code in there for reference, but you don't want it to be active. You can just activate it by taking the comments off, and then it's alive again. So I have this in here sort of commented out so that you can use it as you need to. Next thing, get the data in. So clear first I use in case I already had a data set open and I want to bring something else in. There are different ways to import data in Excel, or Stata. I'm using Excel as the easiest one. So case preserve means don't make everything lowercase, that's a default. First row means read the first row of the spreadsheet as my data names, and then if there's more than one sheet in the workbook, I want to point it towards the right one. You don't need that if there's only one. Then we get into, let's do it sequentially actually. So the same steps in R. Set WD is the analog to CD. Sets the working directory. So then this is the folder place, and then I am reading in the files listed below. So this implicitly has this address in front of it now. So I downloaded a package that allows us to read Excel files. The path is the name of the file with the extension, and then the sheet name clarifies if there's more than one sheet. And then because sometimes data sets import as other kinds, I have this here. So you can have matrices, data frames, tibbles, and tables, and all kinds of stuff in R. So a data frame is what we need it to be. So I just have that in there. Then making new variables. In R, I'm listing the name of the data set. The $sign says, hey, that's the name of the data set divider. Now we're talking about the new variable. So from here, it's new variable name equals old, and now I'm subtracting 85. Now, why 85? I'm centering. Now, how did I know to pick 85?
Was that their lowest value that you were collecting data on?
In these fake people, no. I think I generated ages relatively
Or
normal.
the average age?
Yeah, so I don't know this at this point in the code. I might know that from the sample description, but I will find out in descriptive statistics in just a second what the mean of age is, which is 84.9, so that's why I picked 85.
Okay.
Yep. So new variable equals old variable minus centering constant. Now what if I don't make a new variable and I do this?
It writes over it.
It writes over it. Now that's not a problem if you do it once, but if you need to rerun your code, it'll keep writing over it and subtracting 85, and you're going to get further and further away from the numbers. So don't do that to yourself. Make a new variable. My convention is to put the centering constant at the end of the name, but otherwise what I see people do is something like, _C for centered version, something like that. It's up to you, but make it so you can remember. 9 pounds of grip strength is near the mean for that, so that's why I did that one. So Stata folks, your code is the same but simpler. Gen is the command to do centering. So I have new equals old minus centering constant. Then we're making dummy codes, so binary variables. Dementia group has 3 categories. Now it's up to me how to categorize them, but I'm starting off by making 2 new variables, setting them equal to missing data. And then I'm creating a new version called demnf. That's going to be none versus future. I could put the little v in here if I wanted to, but I was feeling lazy that day, I guess. Up to you. And demnc, which stands for none versus current. So if we're talking about the first group, read these backwards, then make each of these 0. So what have I done conceptually? What decision have I made in using this coding scheme for group 1? by making them both 0. The reference group, yeah. I have decided that group 1 is my reference, and I've decided that by making their new predictor variable 0. So then the intercept will give me the expected outcome for group 1 because that's when the slopes are shut off. Group 2 is going to turn on for the first predictor, and group 3 is going to turn on for the second one. Then, because I'm a good data analyst, I add all my labels. That way someone in the future can be like, what is she doing here? And this is the English translation of that. Also, these labels will show up on your output in various places to make your life easier too. Now, a new thing, actually, before I do that, let me go down to the R code. So the R code looks the same as what we usually have. So the if it's this is in this part right here. Note the 2 equal signs. That's an equality evaluation, not an assignment. So if it's 1, if it's 2, if it's 3, then fill in zeros for the first one, 1, 0, and then 0, 1. Now the last piece here, this part in Stata, and this part in R. What I am doing is something new. You have not seen this yet. I am deliberately removing cases that do not have all of the variables that I'm interested in.
Clean the data.
I wouldn't call it cleaning.
What would you call it?
I would call it making sure that my sample stays consistent across models regardless of what's in the model.
Wow, such long. Very long.
It can be. So this in Stata is first generating a new variable. So eGen is like fancy gen. It has more functions and more stuff in it. Extended gen, maybe? Anyone know? Sam, do you know? You're here today, right? Yeah, he's here. Let's see if he weighs in. I don't know what eGen stands for, but I'm sure someone can Google it for me and find out. I have a new variable I'm creating called nmiss, and it's using a function that's built into Stata called rowmiss. That means the number of missing observations in a row. So I'm first saying, how many of these variables are you missing? And that's a new column. And if the answer is 0, then I keep you. And if the answer is greater than 0, I drop you. Now, why I would do this in practice is because if I add in a predictor, my model has a result, then I add in a new predictor. The people who don't have that new predictor drop out of the model. So the models aren't comparable because they're based on different samples. So you can have some weirdness in terms of what is significant or not, or effect size or not, if they're not based on the same sample. So I'm solving this problem ahead of time by pre-selecting my sample to have all the pieces of information that I'm eventually going to use. And I did that in R with a function I found called complete.cases. So it says, in this data set, use all the rows, that's why there's a comma here, and then search for complete cases based on these 5 variables that I just created. So how many of you think that's a bad idea to remove people? Sam said, or Erica says, thank you, eGen equals extensions to generate. Yeah, extended generate, something like that. Okay, how many of you think that it's a bad idea to kick people out of your model? Everybody should have their hands up. If I have fewer people, what do I have?
Then even less data.
I have less data. If I have less data, I have less power, right? I'm more likely to miss things that are really there. I have noisier results with less people. And if people didn't answer the questions for reasons, then I have a different kind of sample. So, like for instance, if one of these variables was annual income and someone didn't feel like telling nosy survey people that answer, people who don't answer the question about income may not be the same as people who do, right? There are reasons why people decide not to answer certain questions or contribute certain data points. So it doesn't help your inferences either, because then you're not talking about the kind of population you started with. Now, how do I fix that? The answer is not in this class. There are ways to fix it, but it requires different methods of estimation. The good news is that if you're interested in some of that, there is a class being offered this spring, a new class on missing data analysis. It will be using some advanced models though, so I'm not sure if it would be a great fit for this audience, but I just want to point that out there in case you're interested in the topic, that those resources will be available. You need likelihood estimation in order to do missing data. The one thing that you should never ever do is fill in the values. So like SPSS has a thing where it's like, you want me to just put the mean in for this empty cell? Is that cool? Or make a regression line and put the point on the line? Is that cool? No, that's cheating. Don't do that ever. Don't ever fill in data that are not real, even though the software has options for that. The idea is reasonable, like, well, let's fill in the mean and then it won't like change things much. But you're not filling in the error around it that each person would be expected to have. So it is cheating in that sense. So this is the easiest solution to the problem, is kick out cases that have incomplete information, but it's not great for a lot of reasons. Fortunately, simulated data are very cooperative in terms of answering all the questions, so I did not have to deal with that situation here. Okay, so any data set I get, whether it's mine or someone else's, first things first, get to know your variables. This is the cleaning part, right? So I'm using summarize in Stata. That is how you can ask for quantitative variable descriptive information, like mean, standard deviation, minimum, maximum. In R, I am using the psych package, a describe function, and note that I have added this little piece here. This is new. So because R is essentially the wild, wild west of programming, anyone who makes a package can make whatever names of functions they want. And it turned out that I needed another package for this example that also had a function called describe, and it did something else. So if you just say describe, it's like, ooh, which one am I going to use? So to say, use that one from the psych package, I added this little colon thing right here. So I get the same information on steroids out of R. So we got a lot more stuff in here. So right away, I would want to look at this and be like, are these values plausible? Does cognition range from 0 to 44? Like, are these possible values? Are these possible ages? Are these possible grip strengths? And then this is a binary variable, so it should range from 0 to 1. So if any of this stuff is wrong, that's where data cleaning comes in, is to figure out what the values should have been, or to remove that case if they're giving you an impossible answer. So step one. But this also provides information about what reasonable reference points on these variables would be. So for age, I centered at 85. For grip, I centered at 9 pounds per square inch. And how about binary gender? Am I going to center that one?
No.
No, because 0 already means something. In this coding scheme, 0 means man and 1 means woman. So 0 already means something. I don't need to change this.
So you actually would do this before you did your centering step?
Yep, I would import the data, get the descriptives, and then come back and do this part of it to figure out what the values are. Yep. How about cognition as our outcome variable? Did you see code to center that? Did I forget that?
No.
No.
You have a scale of 0 to 44 that you're probably using somewhere where that value came from.
Well, this came from the original sum score range. But have I centered an outcome variable at all this semester? I haven't. You don't need to. Because the intercept is the expected outcome when your predictors are 0. Doesn't need your outcome to be 0. I can only think of a few specific cases in which you might want to do that, and that's where you're trying to test the fixed intercept against some chosen number. So like for instance, if you had a question about whether the expected value at the 0 values for your reference was different than 15. You could answer that question by subtracting 15 from your outcome, and then your null hypothesis would be 15 instead of 0. That's the only situation in which I would do that. So what about for dementia group? Should I add that to my table here and get its mean standard deviation? Dementia group coded 1, 2, 3? No. Would that make any sense? Nope. Would it run? Yeah. Yep. That's the thing about software and AI. It's happy to do what you tell it to. So, no, instead, I would use a different command to figure out what the frequencies are. So it's tabulate in Stata, In R, it's a table command that I embedded prop table so that we have proportions. So in terms of the breakdown of gender, 58% are women, 41% are men. And in terms of the differences between dementia groups, the first group is the largest. As you might imagine, the people who are not going to get dementia are able to participate in this fictitious research study. Then the people who are going to get it during the study, and then people who already have it. So with respect to power, is this ideal, do you think, to have the groups be so lopsided? Probably not. So especially any comparisons with group 3 are going to have limited power because there's so few people in that group relative to the others. Now, can I fix this? Not really. The only way I could fix this was with a different sampling design in which I deliberately tried to recruit the same number of people from group 1 as group 2 as group 3, or I manipulated this variable somehow into equal group sizes. But those options aren't available to me, so we'll just make the best of it. Same information with less labels in R. So now I've gotten a sense of my descriptive statistics for these things. This is information that would all go into your method section. So this would be C table 1 for descriptives for all variables, that kind of thing. Then next is bivariate relationships. Before examining how each of these things predicts cognition uniquely, I want to know how they each relate separately. So here's PW core in Stata, or R core in R. This is the extra package I had to download so I can get p-values. So I have cognition, and note that it abbreviates the name here, so that's just weird, but it does it. And I have age and grip and binary gender. So let's look at each of these here. The first number is a correlation. This is a Pearson correlation in particular. The second number is the associated p-value. So what is the relationship like between age and cognition according to this? Yeah, I'll take gestures. We're making negative slope hands, I think. Getting my arm going. So as age goes up, what happens to cognition?
Goes down.
Goes down.
Makes sense.
And aging is bad for you, apparently. Does it go down like a lot or just like a little bit?
I don't know, what's our unit of measurement?
Yeah. So how would you classify this effect size? Now there are standards by which people can say low or medium or high. Those are somewhat discipline specific, so I don't want to give you rules. But in general, is this a strong correlation? 0.17.
No.
Yeah, what's the highest it can be?
1. Or negative 1 in this case.
Yeah, 1 in absolute value. What's the smallest it can be?
0.
0. So 0.17, I can think of that as if I standardize these variables, for every standardized unit increase in age, cognition would go up by 0.17 standard deviations. I can think of it that way. I can think of it in terms of shared variance. So what is 0.17 squared?
Just under 4%.
Just under 4%. So I can also say the amount of overlap between these things is 4%. That sound like a lot? Doesn't to me. How about cognition and grip strength? A correlation of 0.24.
Going up.
Yeah, as grip strength goes up, cognition goes up. So that means get to the gym to help your brain, right?
Yeah.
Yeah, just reminding folks that this is not causal. This is associative data. How about gender? Negative 0.24 correlated with cognition. Now this one's a little weird because it's a binary. The men are the 0, women are the 1. This is a binary variable.
So women are less.
So who's higher and who's lower? Men are higher and women are lower, and how did you know that? Zero is a reference, yep. So for every 1 unit increase, right, then the 1 group goes down. So even though this isn't a quantitative variable, you can still think of it as a 1 unit increase is moving from the 0 group to the 1 group. So the sign of the correlation, or the slope as it will eventually be, is negative. That means the 1 group is lower and the 0 group is higher. significantly in this case. Now, the correlations among the predictors are also of interest. So age and grip are negatively related. The older you are, as age goes up, grip strength goes down. That's unsurprising. Age and gender are not correlated, which would be good news from the perspective of not confounding these things. So like if most of your sample is older, but the people who are older are all women, then is it age or is it gender? So the fact that these are mostly unrelated would be good news. Oh, but then grip and gender are negatively correlated 0.4.
Women have in general less grip strength than guys.
Yes, the women are weaker in general. So now we have a sense as to how these things relate to each other. Did I forget something? I did. So I have the answer in the box here, but I want you to ponder that for next time. Why these variables are not in my Pearson correlation matrix. Because it's 3:15 and I wanted to leave a cliffhanger. So,
Slide off to the side again.
yeah. I can. So,
Okay.
yeah, that's my cliffhanger. So questions for today as we wrap things up. No, we're good, Zoomers? Yep. All right. Thanks for being here. Come back Thursday for Candy Free for All.
Woo!
Have a good garbage day. Have a good Tuesday. Hang in there. See you next time.